Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
So again, reverting from the frequency table back to your raw data, what you would do is actually look at your observation and then, of course, in ascending order from top to bottom. And the frequency tells us how many times to write 11, how many times to write 12, how many times to write 13. So in a raw, to create a raw data set from this frequency table, it would be 11 trees, 3 11s, I said that the other way around, 5 12s, so write 12 5 times. I write to 5 instead of 12. 5 12s, 2 13s, 1 14, and 4 15s. Right? Go ahead and double check, make sure I have each one of these correct. Right? So yeah, 4 15s, 1 14, 2 13s, 5 12s, and 3 11. So this is the raw data set upon which they constructed the frequency table from. And you can go ahead and do this with any frequency table. But when you have large numbers like 10 5s, okay, this is not even that one. Yeah, when you got large numbers like 23 4 5, it's going to take you a really long time to write down all of those. But when you're working with small frequencies, those small frequencies, you can actually take time and write down the raw data, right? Write down the raw data set. And you could do this to find the median, because I know the median, you would have to calculate the median position and use that. Or another way you can get the median is to actually convert it back to the raw data, and you know how to find the middle. Just X off from and 12 is the median, right? So you can go ahead and do this to actually get the median, or like before, we would have to go ahead, find the median position. Now we already know the median is 12, or you can do what I showed you last week, which is to use the formula n+1 divided by 2 to find the median position. And the total frequency here, 3 plus 5 is 8, 10, 15, right? 15. So 15 plus 1 divided by 2, 8, right? So you would go ahead. 3 plus 5 is 8. We already reached 8, so right away, the median is 12, right? You could go ahead and do this, or you could revert back to this and get the median. So the median is 12. Right? Everyone follow in? Except for those who missed class. I know you would have missed also looking at getting the median. But for those, especially for those that weren't here last time, you guys following?
Sorry, you could repeat that one more time, please. Thank you.
Repeat. Good. So what you have so far, just a refresher, what you have so far in your data set, in your arsenal with regards to statistics, is to take your raw data, put it on a frequency table, and graph it, right? You went through all the types of graphs that you can use, at least the common ones, and you know to interpret them. You've also looked at Central tendencies, which are, like I said before, are statistical values you can use to represent your data set. That tell you something about your data set, right? The mean tell us what the average score is, gives us a rough idea of what the average value of the entire data set is. The mode tell us what was the most popular value, right? Your most observed value, right? And the medium tells us the middle value. And like I said before, we're not going to use the usefulness of the medium will not come until now, right? When we're looking at measures of dispersion. So measures of dispersion, like with central tendencies, are just values that you can use to represent, that tell you something about your data set, right? And what those values are. So first I'm going to do an introduction as usual. Then we're going to look at some measures of dispersion, which are range, interquartile range, and semi-interquartile range. Those three are actually the measures of dispersion. And you can't talk about interquartile range and semi-interquartile range without getting into quartiles, which some will get into before we get right. So that's why it's in this order, right? We'll look at range, right? Then we're gonna look at quartiles before we get into actually calculating interquartile and semi-interquartile ranges. And these, again, these are values, these statistical terms, range, interquartile range, semi-interquartile range, are values you can calculate using your data, right? Using your data. All right, so enough of that. Says it here, right? This is exactly what I'm saying. So the measures of dispersion, 4 commonly used measures of spread, tells us how much your data is spreading, right? Meaning, one way you can think of this is, think of a questionnaire. Think of a particular question on your questionnaire and the answers. You have answer A, B, C, and D. How these values, these ranges, interquartile, semi-interquartile ranges, tell you how well your answers, the person's answers were distributed among those among answer A, B, C, or D. If most persons answered A, of course, you will see that with your medium, but it tells you more of the distribution of the data, right? And those 4 commonly used measures of dispersion are range, interquartile range, semi-interquartile range, which you will look at. You got to be able to calculate. And then there's something called standard deviation. Now, I won't show you guys how to calculate standard deviation. It's not necessary. It's not on the syllabus. So you don't need to know how to calculate standard deviation. I'm not going to teach it here, right? I'm not going to show you guys how to calculate standard deviation, but please note that standard deviation is a measure of dispersion, right? We won't look at it though. You will look at it if you're doing maths. You will look at it if you're doing CAPE. You will look at it if you're doing any sort of maths after high school, right? You will look at standard deviation. And this is the most popularly used. I'm gonna admit that this is the one they use the most. You see this a lot in statisticians, even scientists, even anyone that's dealing with data usually calculate this. Now you will, of course, learn today, but not least for the next 2 sessions, how to get the range, interquartile range, and semi-interquartile range. So moving forward, what is the range, right? Good. So the range, plain and simple, right? The range of a set of data is defined as the difference between the largest and smallest observation, right? So your largest observation subtracted by your smallest observation, that is the range. Can't get any easier than that, right? So for this should say ungrouped or grouped because only group data will have right? So for raw data, we're going to go ahead and use range is equal to the largest observation subtracted by the smallest observation. Of course, the larger your range, the greater your values are dispersed, right? Keep that in mind. So the greater the range, their range of value, the greater the measure of dispersion, right? The greater your data set is being dispersed, right? So this largest observation subtracted by smallest observation. However, for the frequency distribution with grouped data, not correction, not ungrouped, with group data, remember you have classes, class intervals. You will look at the upper boundary limit of the largest observation. So you take the upper boundary of the largest observation, the largest class, the last class, it will be the last class, subtracted by the lower boundary of the smallest observation. That's your first class. Right? So you take the upper boundary of the last class interval and subtract it by the lower boundary of the first class interval. That's another way to think of it. Right? That is it concerning calculating ranges. You look at the largest observation subtracted by the smallest, plain and simple. Okay, so let's look at it for raw data and then we get into frequency distribution. Remember, frequency distribution just speaks of frequency table, right? We're just looking at frequency tables. Look at our first example. Calculating the range from raw data, right? Again, even with our measures of dispersion, we moved on from central tendencies. Even with our measures of dispersion, we got to be able to get it from raw data, frequency table with ungrouped data, and frequency tables with grouped data. We got to be able to get it from any given situation. Now, for this example, the basic wage of workers in a factory, again, placed out in the raw data format, is $148, $175, Calculate the range of the basic wage. Now, again, to calculate the range, range is equal to the largest observation subtracted by the smallest observation. So you got to go ahead and do is in your raw data set, identify the largest observation and the smallest observation. Yeah, I don't know what that one. Good. So we have the largest and smallest observation. Yeah, right. 195 and 148. Just subtract the two and that will give you your range. Doesn't get much simpler than that. Another way, something else you can do, and you probably want to do this if you might have to again find a medium, for instance, is arrange the data in order, in an order, ascending or descending order, like it's arranged here. And when it's arranged, if it's arranged in ascending order, you know that your first observation will be your smallest observation and your last observation will be your largest, right? It's arranged in ascending order. Now, one reason why you might want to do this is, like I said, when you're looking at medium, you need to have your data arranged in ascending order, right? Or descending order, depending on whichever, you will still get the same medium, right? So be careful with that. Yeah, that's if you got to go ahead and find a medium. Otherwise, it's useless to do this, right? But it can be useful if you got to go ahead and find other statistical values, right? That is it. Can't get it easier than this. Largest observation subtracted by the smallest. So let's look at an example with frequency distribution or frequency table, right? So the mass of 50 lambs, right away, you know your total frequency is 50, right? Can't go wrong. Were estimated to the nearest kilogram. The result can be seen in the tabulated below. What value is the range of these estimates? What is the range? Like I said before, you can literally ignore frequency, but I like to read off these frequency tables so you guys can keep, I want you guys to keep reading and interpreting frequency tables. You're gonna have to do it, frequency tables and graphs, but we don't have much graphs to work with. I'm gonna keep doing that with these frequency tables. So again, the first column is our observation column. The second column is our frequency column, right? And this of course tells us this is number of lambs, right? Pay attention to that. We're looking at lambs. So the frequency is number of lambs. I mean, the total frequency or the total number of lambs is 50, right? And what this tells us is that 27, for mass of 27, 4 lambs weigh 27 kilogram. 9 lambs weigh 28, 16 weigh 29, so on and so forth. That's how you interpret. That's the interpretation of this frequency table. Now let's go ahead and actually find what the value is for the range of these estimated masses. Now, like with the, I failed to mention this, but like with the central tendencies, these are values of your observation and not of your frequency, right? So pay attention to your observation more than your frequencies, right? So the calculated, we don't need, right? The largest, the highest observation by the largest. And of course, it's a frequency table. All frequency tables are arranged in ascending order. Well, yeah, in ascending order going down. So right away, you'll know the first observation will be the lowest and the last will be the highest. So there's no need to be sifting through, right? This is how your frequency table is set up. So you should know 33 by minus 27. Back in. Right. That was a mistake on the slide. Even what? So the same mistake came back from before. All right, so largest observation minus the smallest. That'll give you your range. The formula just know that is for grouped data, not ungrouped. And that's when we look at upper and lower boundaries. Be careful. Be careful. Right, that was a mistake on my part just now. Apologies. Before I move off, this is it concerning range. It's as simple as that. Let's move on to quartiles. Just before we get into semi-interquartile range and interquartile ranges, those are two other additional types of ranges that you got to be able to calculate for your data set, right? Now, what is a quartile, right? A quartile is one of 3 values that divide an ordered set. Now, emphasis on ordered. Your data need to have some order, ascending or descending order. That's it. Some ordered set of data into 4 equal parts. So imagine dividing your data set into 4 parts. That is quartile. Now, quartile comes from quarter, right? You know what a quarter is, 1/4. Right? So when you hear quartile, think of quarter, right? I don't even think I need to put the word. We can just put a quarter, right? 1/4, which is a quarter. So quartiles refer to a quarter, right? So you're splitting your data set into 4 parts, 4 quarters, right? Or 4 quartiles, all comes together. So the first quartile, is the value below which 1/4 of your data lies. The second quartile, Q2. All right, I should have hidden this, but you should remember that Q2 is your medium, right? And the medium is the value below which 1/2 of your data lines, or you can think of it as 2/4, right? 2/4, right? So 2/4 of your data line. Let me put that. So you can think of it 1/2 or 2/4, right? Because 2/4 is still 1/2. That's why they use it 1/2. But it's 2/4 of your data set. So a quarter is called the first quartile, the value below which a quarter of your data line is the first quartile, below which 2/4 or 2/4 of your data line is the second quartile, and 3/4 is your fourth quartile. And 4/4 or 1 would be your entire data set. So that's just ignored. So you don't have a fourth quartile, because the fourth quartile would be 4/4, which is 1. And if we were to think of this as splitting points in our data set, it will be the last value, which means that it's your entire data set. So how useful is that? That's not that useful, right? That value is not useful. So we don't have 3 quartiles. We're only going to focus on 3 quartiles, the first, second, and the third. And the symbol for each is in bracket: Q1, quartile 1, first quartile; Q2, quartile 2 or second quartile; Q3, third quartile. And you can think of these are all, if it's Q1, then it's 1/4. If it's Q2, the second quartile, it's 2/4. And if it's Q3, it's 3/4. So remember, these are all quartiles, they're all over 4, right? So that's the way I'll start. We'll start by identifying the medium, and then we work from there. Because as soon as you identify the medium, it's easy to get the other two, right? As soon as you get a second quartile, it's easy to get the other two. Good. So this is animated, so I don't need that. But so first, remember the associated fraction for each of your quartile. And I'll explain what they meant by what these statements mean, right? The value below which 1/4, what those statements actually mean. Where I got this from. Good. So we have before us we have data set. Please notice that our data is arranged in ascending order. It's arranged in a particular order. So this is from raw data. We look at the frequency table just now, and like with your medium, you can already guess how the getting this first and third quartile will be. It's be a similar thing to getting the medium. Good. So 1, 2, 3. I can't count, so I skipped 4 for some reason. 6, and then 7 was skipped also. 8, 9, skip 9, 10, skip 11, 12, and then jump straight to 19, right? Very interesting way to count. But nevertheless, we have our numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Our 9 numbers. Odd number, we know we can identify the middle, right? How again, the simple way to do this is to just X off from back to front until you reach the center value, which is 6. And that is our Q2, our medium, our second quartile. So we more or less, like I said before, know how to get this. So the Q2, the second quartile, is 6, right? It's the value that's in the middle of our data set. Or another way to interpret it is that it's the value below which a half of our data set lie. Now, what does that mean? It means that at this value, from the beginning of our data set up to this value, we reach half of our data. We have half of our data. That's what it means. Right? So half, it's the value below which a half of your data line. It's more or less the middle point of your data set. Right? So half of your data is below this value. So including the value, of course. That's what it means, right? Half of our data set is below this value. That's all it means. That's all that statement, those statements meant. So we identified the second quartile. Now imagine, so what I want you to do now is to, and that's what you're going to do. This is the way you're going to identify these quartiles, right? This is the way I'm going to show you to do it, is to split the data in half. Well, the raw data set, if it's a raw data, split it in half. You'll get, by using your Q2, split it in half and ignore the other half. So for now, we look at the first half of the data set. Why? Because we're looking at the first quartile, right? So you got Q2, the second quartile. Let's get the first quartile. Now the first quartile will be the middle value for the first half of the data set, and the third quartile will be the middle value or the medium for the third half of your data set, for the second half of your data set, sorry, right? That's one way, that's the simplest way to get them, right? use the middle, use the medium to split the data in the data set in half, and then identify within your halves, identify the halves of those halves to get these other two. So in the first half of the data set, let's identify the first quartile. All right. So like before, remember how to do this? Keep Xing off until you reach the middle. Now, if we keep Xing off, we'll end up with nothing. So two values are within the middle of the data. And like Brianna pointed out last time this happened, the way to get the middle value is to find the average between these two values, right? Meaning that we add them and divide them by 2. So 2 plus 3 divided by 2 is 2.5. And you've identified the first quartile. We okay so far? More or less, you've identified the medium for the first half of your data set. That's what Q1 is, right? It's a quarter. It's half of a half. Half of a half is a quarter, if you didn't know that before. If I split the pizza in half and then I split the half of the pizza in another half, if we look at the whole pizza, it's actually a quarter of the pizza, right? Half of a half is a quarter. So that's the concept we're using. So now we've identified the first quartile, that's 2.5. Let's go ahead to the second half of our data set. Again, you can ignore the first half, right? You can ignore it using from the point from your Q2 value backwards, ignore all of this and just get the half or the medium for the second half of your data. And that is Q3, right? Third quartile. And again, we have two values in the middle, two medium values for this half. And like Rihanna mentioned, we add those two and divide them by 2, find the average. So 10 plus 12 divided by 2, 22 divided by 2 gives us 11, right? That is it. That is it. And here is what I was saying. So the second quartile is the middle value of your whole data set. The first quartile is the middle value of the top half or the first half of your data set. And the third quartile is the middle value for the bottom half or the latter half, the last half of your data. Right? That is it. So all these quartiles, you can think of them as halves of half. The first and second quartile, the first and third quartile, you can think of them as halves of halves, right? And the second quartile is half of the entire data set. Good. So as you can imagine, so for identifying the first, second, and third quartile from a distribution, which is with an ungrouped data, like for the medium, which was Q2, the rank of the quartile must be identified using these formulas. So we got to get the position, like before, we got to get the position, and then we get the quartile, right? So we got to get the medium. Just like with the medium position, we got to get quartile, the first quartile position, third quartile position, and you notice with the formula, it's easy to remember the formula, n plus 1 divided by 2. But if it's the first quartile, it's n plus 1 divided by 4. If it's the third quartile, it's n plus 1 times 3 divided by 4. So the fractions are important. They just change based on what quartile it is. And I more or less taught you the trick into identifying what fraction is going to be in front here. Right, so it's n plus 1, but if the first quartile is 1 over 4, if the second quartile is 2 over 4, which is a half, like I explained before, and if it's the third quartile, it's 2 over 4. Okay, and like I said, a fourth quartile would be absolutely useless because 4 over 4 is 1, and that's your entire data set. Okay. Now, I will give you guys a break, right? I'll give you guys a break just before we actually look at an example. Right? So this is the example we're going to look at after the break. I'm going to give you guys 5 minutes. I know there's only 5 minutes breaks. I'm giving you guys literally without it, got the time. Right? So 5 minute break, and then we're going to look at getting these quartiles for our frequency distribution. It's the same. Remember, these are still quartiles. The same. I can argue that it's the same concept like this. However, because it's arranging a frequency distribution, it's a bit more challenging to get those quartiles. Right, so we're gonna look at them in a few. They're the hard part of actually having to use the formulas to identify the first, second, and third quartiles of a frequency data, right? The frequency distribution of a frequency. Again, frequency table. Now the mass of 100 pupils in a school, again 100 pupils indicates our total frequency will be 100, are shown in a frequency table below. Now again, frequency table observation column first. By now you should fed up with me saying this. And the frequency column is next, right? Here it says number of pupils. We understand that that is the frequency, right? So 7 pupils weigh 51 kilograms, 52, 8 pupils weigh 52, so on and so forth, and for a total of 100 pupils. Okay. Good, so now let's identify the quartiles for the data set. Right, so let's start with the one we know and kind of maybe love is the medium, right? Let's start with the medium, and remember the medium. To get the medium from the frequency table, we need to calculate the medium position using the formula I just showed you. So for Q2, the medium, it's a half of n plus 1. Remember, n plus 1, n is the total frequency. I did not indicate that here, but for the sake of the notes, I will again reiterate that n is total frequency, right? 1 is 1, everything else is constant. So, all right, just remember this, n is total frequency. Right, so and the total frequency plus 1. Nobody asked, but yeah, the total frequency plus 1 divided by 2, or total frequency plus 1 multiplied by a half, it's the same thing, mathematically equivalent. So 100 plus the total frequency is 100. We don't need to go ahead and total this. 100 plus 1 divided by 2 is 50.5. So the position of the medium is 50.5. And so we got to go ahead and start counting. Right, we got to use this 50.5 position to locate the corresponding observation or observations, depending, to find their average if necessary, find the average if necessary. And never, in a nutshell, we're using this value to get the median, right? The position to get the median. So let's look at our frequency column, or number of students, number of pupils, sorry, and get cumulative frequency and add until we reach 50, a value more than or equal to 50. So 15 plus, so 7 plus 8, 15, 15 plus 10, 25, we can add like that, or 7 plus 8 plus 10 is 25. Easier to just add. So add, coming down, 25 plus 12, 37. We keep going until we reach a value that's equal to or more than 15. So we reach 50 now. So because this value is 50, which is the whole number for a medium position, instead of stopping at 50, we have to go one more value down. We got to go more than 50, because 50.5 is between 50 and the next cumulative frequency, right? For those of you that weren't here last class, that might have been a bit confusing, but for those of you that were, remember what to do here, right? If it's because it's 50, we gotta go another step down and stop, right? 50.5. But because this value is 50, which is the whole number for our 50.5, we got to go ahead and take the observation both for the 50 and the value more than our 50.5, right? So because what happens is that our 50, because this is 50, our value is stretching between these two observations, right? Stretching between these two observations. So we got to take both of them. It tells us that our observation is between 55 and 56, right? Right, so we got to take both of them, 55 and 56, and find the average. Again, like Rihanna would have mentioned, find the average between 55 and 56, and that will give us our Q2, right? Our second quartile. 55 plus 56 divided by 2. Again, that's the average, 55.5 kilograms, right? Now, remember, our quartiles, our ranges, all information of upon our observation, not exactly our frequency, even though they're using our frequency to get those values, they're more or less of the observation. So this is not your medium, it's the position of the medium. This is the actual medium, right? So be careful. Good, so, okay, so far we're moving on to the second quartile. Not a second quartile. We finished with quartile 2. We're going to move on to the third quartile. So we're going to identify each quartile for the same data set, right? So even though I might look like I'm switching slides, all I'm doing is clearing out everything and keeping, of course, what we already know on a new slide, right? Good. So again, same procedure like before, but now we're going to look at the first quartile, right? Q1. So again, we need a total frequency, which we already know is 100. And for Q1, to find the position of Q1, it's 1/4 n plus 1, right? Again, n is the total frequency. Just neatly put that here. N is equal to 1. So 100 plus 1, and now we're going to multiply it by a quarter, or 100 plus 1 divided by 4. We end up with 25.25, right? So what do we do with this value? It's not your quartile, it's not the first quartile, it's the first quartile position. So we got to use it to identify where our first quartile is. So let's go ahead again and start. Let's take, now what we're gonna, let's go ahead and start adding, but what we're gonna look at is for value equal to 25.25 or less than 25.25. Right, so first is 15. You already know that all right, we stop at 25. Now because 25 is the whole number of the position, we just go one step down and stop right there. And this being the case where 25 is the whole number. Now third is 25 is not more than or equal to 25.25. So it's not, so that's not where we stop. But like I explained just now, because the whole number is 25, right? Because the whole number of, because we spot the whole number being 25, that tells us that the observation is stretching between these two, right? The medium, the quartile, the first quartile is being stretched between these two observations. If we land plumb on the value, of course, you know, that just take it as it is, but because we're working with decimals, this can happen. Let's see an example where it doesn't go, right? So again, 25 stretching, because it's 25.25, it goes over into the second observation, 54, and we're going to take the average between these two. Right, so again, just add them, divide them by 2. So 53 plus 54 divided by 2, 53.5 is our first quartile. Right, our first quartile. All right. Again, let's do the same thing. The total frequency is 100. N is equal to 100. But now we're going to find the third quartile. same thing as before, but this time the formula is a bit different to get the quartile position. So the third quartile is 3/4, 100 plus 1, and that is 75.75. So now we're going to add until we reach a value either equal to or less than 75.75, right? Add as you going down, add as you go down, add as you go. Now these values you already know, but moving forward, 65, 77. 77 is more than 75, so we stop, right? Now we're just gonna take 57 as the third quartile. There's no need for us to do that stretching between any two because the whole number, this whole number, if this was 75, then we would have to stretch it between 56 and 57. But because this is just 65, the entire, we can safely say that the quartile or the medium, not the medium, the third quartile is located in this observation, right? The third quartile is 57, right? We can safely just stop and say this. If this was 65, then 75, then you would find the average between these two. So you just look for the value equal to or more than, right? And if you find a whole number, if you're working with a decimal position and you find a whole number, then a whole number of the whole number of your decimals of your decimal, then it's stretching between two observations and you got to find the average. If that does not happen, then you just take it when you reach the most, when you reach a value equal to or more, right? So right before you have a frequency table of masses of students and number of pupils. Now the total frequency is laid out below as 119. What I want you to do is to give me Q1, Q2, and Q3 for these, for the data set, right? The first, second, and third quartile. That will take us to the end of class. Right, I would have loved for you guys. Okay, get on it. You can get on it now. Right, try to get the first, second, and third quartiles for this data set. The total frequencies is below. You have the formulas. I've went through examples. Let's see you try this yourself.